Hey, in today's lesson we are going to find the distance between 2 points on a coordinate plane. I encourage you that throughout this video, I encourage you to pause it at any point and work the problem out yourself on your own coordinate plane. Use a dry erase board or whatever you have, and then restart it and see if you did that problem right. So here's distance on a coordinate plane. I want to start off by having you plot these 4 points. These 4 points are going to give you a shape. I want you to draw in that shape, and we're going to find the area and the perimeter of that shape. So feel free to pause it now and try it yourself. I'm going to go ahead and do it, and you can restart it after you're done. So the first point is 4, 3. Second point is 4, -1. -2, 3. And -2, -1. So when I connect these points, this makes a rectangle. We'll need to know the dimensions of this rectangle, so I'm going to count, and hopefully you have your own board so you can see it a little bit better. But the length across the top is 1, 2, 3, 4, 5, 6, and it is 1, 2, 3, 4 tall. So this is a 6 by 4 rectangle. It's really important that you know how to get that 6 by 4. Sometimes the student gets one more because they don't count it right. So be sure you really look closely and make sure you see why it's a 6 by 4. So that would make the perimeter of this rectangle. We would do 6 plus 4 plus 6 plus 4. So the perimeter is 20, and I'll just label it with units. And that makes the area be 24 units squared. Okay. So counting the distance, what the length and width of that rectangle was on a perfectly horizontal line or a perfectly vertical line, that's pretty doable. Today, the big point is that we're going to have to find the distance between 2 points that maybe aren't perfectly horizontal or perfectly vertical. So clear your board off, and here we go again. I actually want to find the distance between the coordinates 3, 4 and -2, -3. So 3, 4. Get on the other side. And -2, -3. Those points are diagonal, and I want to know how far is it from this point to this point, but it's a diagonal line. And sometimes I get kids that want to just count the diagonal. So, well, that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. They touched 11 boxes, so it's 11 units long. And so no, the diagonal line is not the same as the horizontal line. If you have a square, and this is 1 unit, and this is 1 unit, well, this diagonal line here is not the same as 1 unit. It's longer than 1 unit. So we have to do this, and we've been working on Pythagorean theorem, so hopefully you've got that concept in your back pocket that you can pull out. If I draw in an imaginary line here and here, I have made a right triangle. And this right triangle, the base of this right triangle, or one of the legs of this right triangle, is 1, 2, 3, 4, 5. And the height is 1, 2, 3, 4, 5, 6, 7. And so I know both legs, and now I'm missing the hypotenuse. So I'm going to do 5 squared plus 7 squared equals the hypotenuse squared. So 25 plus 49 equals the hypotenuse squared. 25 plus 49 is 74. I'm going to find the square root of both sides. So this distance is the square root of 74, which is approximately, and if you have your calculator, which I don't, so let me find me a calculator super duper fast. Hold on, there's one right here. The square root of 74 is approximately 8.6. So that distance would be approximately 8.6 units. Okay. All right. Let's do one more here, and you feel free to pause it and try it yourself. But my coordinates are -4, 5 and 3, -5. You can start me back up when you've done the problem. -4, 5 and 3 negative 5. Oh, that's a long one. So we want the distance from here to here. So we're going to draw in an imaginary line coming down, an imaginary line going across. There's my right angle. This leg is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is 1, 2, 3, 4, 5, 6, 7. So the legs are 10 and 7. I'll use C this time instead of H. So 10 squared is 100 plus 49. That's 149 equals C squared. I'm going to find the square root. Find the square root. And so C is the square root of 149, which is approximately 12.2. Okay, that's the distance on a coordinate plane. We'll see you next time.